Hi, this is Group 3's demo for Project 1, code signing with ECDSA. Let's walk through our project files. So starting up, we have a README file. So this explains the project structure, requirements, and setup instructions, and how each script works. And we used Python and ECDSA library along with PyCryptodome. So we have given instruction for that, and the project structure of how the project is structured. We have the workflow of it. We have generate keys.py, which generates the key pair, private and public keys to private key.pem and public key.pem. And we have product.py, sign product.py, and validator.py. So this is basically what we have in README. And let's go through generate keys.py. So if you run it, okay, let me run, then it should create private key.pem and public key.pem. So first off, this is what the private key.pem that gets generated when we run the generate keys.py. And also we have public key.pem alongside with it. So these will be used in next steps. So next we have product.py. This is our product software. It prints a message showing the software's origin, like I am a software made by EUID. That's the number there. And now let's create a digital signature for this file. So we have sign product.py in order to do that. So this script reads the product file, hashes its contents using SHA-256, and signs the hash using our private key. It then writes the digital signature to the product.sig. We'll now verify the product using the public key and this signature. So first of all, so after running it, we'll get this product.sig file, which contains the digital signature that we just created. And now we have to verify the product using the public key and this signature. So for that, we have validator.py. So this script simulates the user. It loads the public key, verifies the product's signature, and only allows execution if the file is authentic. So since the product was not modified, let's see what happens when we run this. So it says execution allowed, and it shows us the verified public key of the vendor. Okay, and it executes the product, and it shows that I was a software made by this, which was in our like the product.py, this product software, right? Now what we have to do is let's simulate an attack. So we need to modify the product by adding malicious code in that. So we have I have it commented here, so let's uncomment that. So if we run the validator again with the product.py modified, so let's see how that goes. So it says verified public key of the vendor, and now that the code has been like modified, let's see, running it again, it says it gives us the public key, but the certification, it says the execution is denied, and like the previous code, it does not give us the result of what we have in product.py. So it does not show us the product since the product was modified. So that's basically what we had to do for the product. So, and yeah, you can look at the readme.file, MD file. We also have the sample examples, the outputs of how your output should look like once you modify this. And this is it for the project 1. Thank you.